All right, so this is going to be a quick video on collision testing. So collision is something that occurs when we have two objects in our games that basically intersect. They overlap with one another. And there's a lot of different formats of collision detection depending on the type of game we're building, whether it's 2D, whether it's 3D. And the way that collision detection works is basically we have to understand the shapes that our objects are in. So for example, if I'm talking about a ball, that might be a circle. If I'm talking about an image, we know it has a bounding rectangle. Sometimes it might just be a mouse pointer or something along those lines. It could be awkward shapes like polygons and things like that. And we can do collision testing between all of them. We can do rectangle to circle and polygon to a point and all these different things. But most of those collision tests are very uncommon, and they're also very expensive to do in terms of the CPU and processing that's involved. So built into MonoGame, there are two types of tests which we are going to refer to as basic collision tests. And these are the two most common forms of collision testing that are collisions that occur. Now, typically that involves when we want to decide whether two images collide, or when we want a point to test whether a point is inside of a rectangle. So for example, that might be if you're clicking on one of the objects in your game. Maybe it's a point and click game like Cookie Clicker or something like that. You want to know whether you're clicking inside the cookie, or maybe it's something like setting up buttons and you want to know whether you've clicked inside the button. It doesn't always have to be with clicking. It could just be with any point inside of any rectangle. Okay, so that's the basics, but how do we go about doing it? What does that actually mean? So in terms of my two examples here, we see two characters. So imagine these two characters are images. Now I've drawn their bounding boxes around them, but those bounding boxes we know we don't actually see in the game. But let's pretend that they're there for now. And in order to demonstrate what I'm talking about here is what we're trying to do is we want to see when their two bounding boxes, their two destination rectangles overlap with one another. So when we're talking about this, let's say I have this guy right here, and I move this over, I can see that the head is clearly overlapping with the foot there. That would definitely be a collision. But the thing is, we're not just testing the images with this, we're actually just testing the rectangles. So that would still be considered a collision. Now you might be like, but that's not accurate. So this is what we call a false positive. All right, so it's giving us a positive result saying, yes, it is a collision. But from our visual standpoint, no, it doesn't look like one. And we see these a lot. We see this a lot in old school games where you'd get like a headshot or something like that, and the bullet's nowhere near the character's head. And that's because the bounding box around their head is way too big, and it looks awkward. Now, is there a way around this? Yes, there is. So that's that more complex collision detection that I was talking about. We could even do it with a simplified version of this, where we, once we've decided that there's a collision between these two boxes, then we could break the body down and make more boxes around the individual body parts, maybe a box for the head, box for the body, box for each of the feet, and then we could test those boxes to see whether they collide with the boxes of the other one. If that's the case, then you know you have a much more accurate representation. But let's go with what we have here. So in order to test to see whether two images or two bounding rectangles collide, we have to use one of two methods that exist inside of MonoGame. The first one is called the intersects method. Intersects. And this will tell us whether one rectangle intersects with another rectangle. Okay? And the other one we're going to use is when we have a point intersecting with a rectangle. So really we're going to think about it as that point is contained within that rectangle. So maybe I clicked on the screen somewhere and I want to know whether the point that I clicked at exists inside of my button or inside of my image or something like that. In order to do that, we're going to learn a second method called contains. And that simply is, does a rectangle contain a point? Okay? Now, going into code, I have come up with a demo here to kind of demonstrate this. So let me just open this up here, make sure I'm opening up the correct one. There we go. So in this demo, if I run the program, what you're seeing right now is just a very basic program with a few images drawn on the screen. We've got a coin, we've got a question block, we've got a start button, and we've got this rounded click button, okay? Now, what I'm going to do is a few things. First thing we're going to do is we're going to get this coin moving across the screen. We're going to do it in the most basic way possible simply by adding a speed to its rectangle's X value every single update. when this coin runs into this question block, when it intersects with this question block, we're going to reset it back to its starting position of x is equal to 0. And that's all we're going to do. Nothing more than that. So we already know how to move our stuff. Oops, I guess I should stop it from running. So in our case, because we're not using a true position, we're just using the rectangle, all I'm going to do is add the coin's speed to the coin's rectangle. Now I've already created all these variables and loaded everything up. So all we're doing is working with the starting code. So I have a coin speed variable, and I'm going to add that to the coin's rectangle. Okay, where are we here? There it is, move coin. So I'm going to say coin rec.x is equal to coin rec.x plus coin speed. Okay. Now again, I could shorten this to simply plus equals coin speed. That works. But as soon as I did this, we should already get the coin moving. And it's moving at a speed of 3 pixels per update. Okay. Now it crossed that question block, but nothing happened. Nothing happened because we didn't do any collision tests. So right below here, we're going to use that intersects method that we talked about. Intersects. If one rectangle intersects with another rectangle. In this case, I want to know if my coin rec, so if coin rec dot intersects with, and now I can pass in a rectangle. So in this case, I want to use, let's see, we're going to use our question block, question rec, what did we call it? Block rec? There it is, block rec. So if that occurs, I get to do my action, whatever action I want. So in this case, I'm going to put the coin rec dot x back equal to 0. So basically, I'm resetting the coin. So we're going to hit run, and we're going to move that coin across the screen, and dink, and it goes back immediately, and it continues to move because nothing told it to stop moving. All right, so we just set that up there. So that's intersection. That's all there is to it, to know whether two images collide. Now, when I run this, you look at that and you're like, that coin is not a perfect box. There's some empty space there. And you know what? That's true. So that's a little bit of an error of margins, or margin of error. So we have to realize that we are going to get some false positives using this strategy. Most of the time, it's not going to be an issue. Another type of error that we might get is if we're working with small objects that are moving really fast. Let's say, for example, you're shooting a bullet across the screen and it's moving at a rate of, let's say 60 pixels per update. That means in one update, it may be right here, right to the left of the question block. And then after one update, it may be past the question block. So as far as the logic is concerned, it's never overlapping. So that can be a problem depending on the type of game we're building. So the solution, the most basic solution is either make your bullet bigger, which you see in all old school NES games and stuff like that, or slow your bullet down a little bit. Also a strategy that was used in those old games. There are other ways to go about it, but they're much more expensive on the CPU to actually do. Okay, so the next thing I wanted to do is I only want that coin to move when I click that start button. So we're going to say, you know what, don't move the coin unless I click start. If I hit start again, pause the movement, stop moving it for a moment. So we're going to solve this problem with a Boolean variable. So I've created a bool called moveCoin, and at the beginning I've set it equal to false. So I only actually want to update its position if moveCoin is true. So I can put that if statement simply right around here. If moveCoin is equal to true, then I'm going to move the coin. So now you'll see, since it starts out as false, the coin's not moving anymore. The only way that coin's going to move is if we click on the start button. Okay, so now we have to actually test to see whether we clicked and if we clicked inside that start button. So I have my mouse variable right here, so I can use this. And I want to make sure that it's a new press. So I also set up my previous mouse like we did in the input lesson. So I'm going to say if mouse.left button is equal to button state.pressed, and it previously was not pressed. So previous mouse.left button is not equal to button state.pressed. So if it's currently pressed but previously was not pressed, that's a new click. Awesome. So now that I know that I've clicked on the screen, Now I want to test to see where I clicked, see if I clicked inside my start button rec. So I could use now we're going to use the .contains method. This one right here. We're checking to see whether this mouse right here, oops, there it is, this thing has clicked inside or not. So if now I have my start button rec, I want to see whether I clicked inside of, oops, rec .contains. So if my start button rec .contains, now I have a few options that I can use here. You can see that there's quite a few different options, but the ones we really care about is you can add a point, and that is if you do mouse.position, that's a point. Great, that's what we're going to use. Alternatively, you can actually check to see whether an entire rectangle is inside of another rectangle. Be careful, don't mix this one up with the intersects method because those are not the same thing. In order for this one to be true, that second rectangle has to be completely enclosed within the first one, which is not very common. We could also pass in a vector 2, or we could pass in an x and y as a float, or in an x and y as an integer. The rest of them are little garbledy stuff that you haven't learned yet, so just ignore those. All right, so in our case, we just want the mouse.position. So if the mouse position is inside of the start button and we clicked on the screen, that's good enough for us. So we want to start the movement of the coin. So we're going to set move coin equal to true. That's going to turn it on. But remember, what we actually said was, I want that button to both turn it on and stop it. I'm clicking right now, but it's not stopping. So instead of setting it equal to true here, I could do some logic in here that says, well, if move coin is equal to true, then I want to set it to false. Oops, I don't know where I keep getting this extra T from. Else set it to true. And that's perfectly valid, but that's a lot of code. Alternatively, we could simplify it. Just say move coin is equal to the opposite of what move coin currently is. And then we don't need any if statements at all. It'll simply say, give me the opposite of whatever it currently is, and now store that back in there. So it basically reverses it, toggles it on and off. So now every time I click, I can click it again to pause it. Not really pausing it, I'm simply just turning that bool to false or true, and since the movement code only occurs when I click on that, that's all that matters. So I have this other button here. This button, what we're going to do with this button is every time we click it, we're going to force the coin to reset back to X to 0. So I can do another click. Now the question is, do I need to check whether I've clicked on this? Do I need to repeat this whole thing again for, let's say the click button? Click button? What did I call that button? What did I call that button? Let's go find out. I called that one round button. Round button, because it's round, I guess. Round button rec. So if you look at this code is basically identical. Because I'm seeing here, well, did I click on the start button? Else if did I click on the round button? You notice that both of these are checking whether I clicked first. That's wasteful because neither of these actions are going to occur unless I click in the first place. So what we're going to do is, as opposed to duplicating our efforts, we're just going to take this and put this right in here. So now, no button click testing is going to occur unless we get a click in the first place. So none of this logic is ever going to run. Otherwise, we're wasting extra comparisons. So now I can start it. I can reset it. Oh, why did I get an error here? Because I actually copy and pasted everything, and rather than actually resetting it back to its position, I just toggled it again. So let's put this back to its position. So it's move coin rec dot x is equal to 0. So we're resetting it back. Move coin rec, oh, coin rec, just coin rec. Try it again. So we can start it, we can pause it, we can start it, we can return it, pop, pop, pop. We can pause it, and we can still return it. It still does the same thing. If I reset it and click it again, all it's doing is resetting it continually here. And that is basic collision detection. You learned how to do intersection between two rectangles, as well as contains, between a rectangle and a point.